So finishing up the example here in the back of practice quiz 2, I should say, we, in the last video towards the end, we talked about the parent function y equals log base 2 of x, and which looks like this, and it has a key point of 1, 0. So the key point on the log graph is 1, 0. Also, something important to remember is that the logarithmic functions have a vertical asymptote and the exponential functions have a horizontal asymptote. That's why I wrote the words like this, logarithmic and exponential. So where's the vertical asymptote on the log function, the parent function? It's x equals 0 is the vertical asymptote on the parent function, or for the parent function y equals log base 2 of x. So all we have to do is apply the transformations. As long as we know these key parts of the log function parent, we can apply the transformations and follow the key point and follow the vertical asymptote around so we can graph this transformation of the parent function properly. First, we're going to start with the a less than 0. So if a is negative 1, we're going to be transforming this graph by reflecting it about the x-axis. So negative, the opposite of log, means that we're going to reflect. Reflecting this green graph, the log base 2 of x, is just like folding the paper over the x-axis, reflecting about the x-axis. We've done that a million times. So hopefully this is becoming something, okay, I got it. Well, there's a reflection, there's the blue graph. Now, all we have to do is again, our h and our k are going to tell us how far to move that key point and where to move the vertical asymptote. So the key point, because h is negative 4, is going to move to the left 4 units. So that key point right there, which is still at 1, 0, even though we reflected the graph about the x-axis, we're going to move it to the left 4 units. 1, 2, 3, 4. And then we're also going to move it down, because k is negative 2, down 2 units. 1, 2. So there's our new key point, and it's going to look just like the blue graph. But let's make sure we put in our vertical asymptote, which, because we moved the graph to the left 4 units, that vertical asymptote, 1, 2, 3, 4, moved to the left 4 units. So there's our vertical asymptote of our transformation. And then again, the blue graph, that blue dotted graph, is what our graph looked like before we moved it left 4 and down 2. So we just make it look the same. Oops. I meant to draw that in blue. So we make it, oh gosh, paper, something's going on here. I meant to draw that right next to the vertical asymptote, right through the key point. And now, again, identifying that the key point has coordinates 1, 2, 3, 1, 2, negative 3, negative 2. So that's the key point. We have our asymptote. The asymptote is x equals negative 1, 2, 3, 4. And we can put that down there in our chart as well. So we've got the graph, we've got our chart, and let's go ahead and write down the vertical asymptote. There are no horizontal asymptotes. The domain, if you look at this, the first x value you get to is negative 4. You go all the way to infinity, but you don't actually hit negative 4, so we're going to use parentheses for that. The range for all logarithmic functions is all real numbers. You can write it as y is greater than or equal to, y such that y is an element of all real numbers. Or that's probably not a way you're going to write it. Or you could write it as negative infinity to infinity in the y direction. Anyway, increasing. So we can see that the function is not increasing. The y values are always getting smaller as you move from left to right. So increasing on no interval, decreasing from negative 4 to infinity over the entire domain. The x-intercept, well, that's what we're going to have to figure out here. X-intercept, if we set the negative log base 2 of x plus 4 minus 2 equal to 0, then we want to solve this equation. I'm going to go ahead and add 2 to both sides. Negative log base 2 of x plus 4 equals 2. I'm going to divide both sides by negative 1 as well. So we get negative 2 divided by negative 1 is negative 2. So here we have log base 2 of x plus 4 equals negative 2. Well, we know how to solve those equations. Our variables wrapped up in our argument. So we're going to rewrite this using exponents. 2 to the negative 2 equals x plus 4. Well, 2 to the negative 2, we should know that to be 1/4. And then if we subtract 4 from both sides, we get 1/4 minus 4. Now, 4 is also written as 16/4 because when we add or subtract fractions, we want to go ahead and get a common denominator. 1 minus 16 is negative 15. So we have negative 15/4 is x. So therefore our x-intercept is negative 15/4, comma, 0. And then our y-intercept, if we let x equal 0, so let me put the y-intercept up here, y-intercept, let x equal 0, we get y equals negative log base 2 of 4 minus 2. Well, log base 2 of 4 has a value of 2, and negative 2 minus 2 is negative 4. So we get negative 0, comma, negative 4 for the y-intercept. There's no max, no min, and yes, it's 1 to 1. I guess in the next video I'll show you how to find the inverse.